The first thing is, this is not a basic TDD talk, and I won't explain how to do TDD, right? So I would expect you to understand at least that TDD is a process by which we write tests before we write code, and there is a cycle of red, green, and refactor where we write a failing test. We then get that test to pass, and then we do any refactoring to improve the quality of our code. Right? You need to know kind of that much. It doesn't matter if you're practicing TDD currently. It just matters that you understand kind of what TDD is about and how it generally gets presented. The other thing about this talk is I will definitely be having I will be criticizing what is often seen as the prevailing approach to test-driven development. Right? I'll be criticizing a kind of approach based on unit tests, mocks, everything else, and even Gherkin-based syntax style acceptance tests. If you are deeply wedded to those and no one is ever going to persuade you that that is the wrong way of doing something, you may want to find somebody else to talk to, because that is what I'm going to try and do today. And if that's something you're going to go, I don't want to hear any of that, right? No point in you being here, right? If you have an open mind, we'll try and explain different ways of doing things, right? And if you've tried TDD and you have bounced off it, this may help you understand why, and may help you understand a way that may work for you better, right? Hopefully, you will be able to write simpler, better tests. This is not a code-based talk as well, right? This is a theory-based talk. It explains the theory of how you do TDD correctly. So if you want something demo-heavy, that isn't this talk either, all right? So anyone who wants to run away, I am really happy that you go and find the talk that will work for you, rather than sort of sitting through my talk and being disappointed because it didn't give you what you wanted, right? It's your time. I don't want to waste it. All right. Most of this is dull. I tend to call out the point at the bottom. There is often in lecture-style relationships a bit of a impression that I am somehow, the expert and you are not. We're all just software engineers. I just got lucky enough early on in my career to have to go and talk at the user group I was running. We all had to share talking because there were no experts that we could draw on in the early days of .NET. So I got past the confidence issue of standing up and talking to you all, but I'm no smarter than any of you, all right? And you could do this. You just need to get audiences like user groups and stuff locally where you can build up the confidence to talk in front of people. .NET developers in the room? I work on an open source project for messaging called Brighter and doing CQRS. We are very friendly towards open source contribution. Other open source and commercial open source messaging frameworks do exist. We're not better or worse, but give us a try. All right, what's the agenda? There's not really an agenda. Actually, clean architecture is not on there anymore, I don't think. We're just going to talk about the fallacies of TDD and the principles. Right? Okay. The first and perhaps the most significant fallacy of test-driven development is that developers write unit tests. Nothing could be further from the truth. TDD has nothing, zero, to do with unit tests. So if I look on Wikipedia, I can get a reasonable definition of unit testing, right? Wikipedia says, to isolate issues that may arise, each test case should be tested independently. Substitutes, such as method stubs, mock objects, fakes, and test harnesses, can be used to assist testing a module in isolation. What does that mean, right? So once upon a time, when we talked about how we were going to automate testing, we tested modules. Modules are nebuliously defined, right? It could be a class, it could be much bigger. And the idea was that module was treated as a black box, and your test probed the module from the outside, and you wanted to make sure that any failures your testing gave you were inside the box. So any dependencies that box have, you would replace with a fake or a substitute. That's classical automated testing. Okay. The problem is trying to apply this as a paradigm to test-driven development. So what happened was, when test-driven development emerged, some people who were familiar with automated testing assumed and began to teach other people TDD on the basis that it was just automated testing and it's not. So there are some problems with that, right? The first problem is there's a lot of focus on isolation in TDD, right? The idea is that for defect localization, I need to understand that all the errors are in this component, not one of its collaborators. Therefore, I must use substitutes that I understand for all of its collaborators. Test doubles are a term we tend to use to describe these things. The idea is of like a stunt double, right? Something that stands in for the actor whom we can't expose to danger. And so that what happens in a lot of people who are influenced by unit testing is they take a class, because they decide that's the equivalent of a module from automated software engineering testing, and they replace all of its dependencies with substitutes. And eventually what this led to was a paradigm of thought in test-driven development, sometimes called need-driven development. Those of you who have read the book, Growing Object-Oriented Software with Tests, this book espouses particularly this philosophy of what's called need-driven development. It's a variation on the test-driven development process where code is written from the outside in. So in other words, you start effectively at the outside with the kind of function or method that you're getting under test. And all dependent upon code is replaced by mock objects that verify the expected indirect outputs of the code being written. So in other words, if I have any kind of collaborator, then I'm going to replace it with a substitute, and I'm going to verify in my test the calls I make to that substitute. One of the issues here is that generally this involves upfront design. I have to either understand, perhaps I did CIC cards, perhaps I had a whiteboard, how I'm partitioning my domain space into objects. Because I have to know, well, this responsibility isn't the thing under test, it's the responsibility of something else, which I will effectively replace with a mock or a stub. So I'm doing upfront design, I'm not letting the tests inform my design. Another alternative to this, which is the one that Growing Object-Oriented with Software with Tests tends to basically offer, is that as you begin to do your implementation in response to the test, you realize, oh, this next bit probably needs to be another class. The responsibility needs to be handed off. So at that point, I'm doing discovery, so I will now write my test for that mock, right? There's an overall problem with this, right, that's basically began to hamper a lot of our development. And that is that essentially, we now, in our test, understand the implementation details of the method or class that we are going to basically test. We must understand its details because we have to understand the interaction it has with collaborators in order to get its job done. We also tend to get forced into a world where most of those collaborators are public, things that we can otherwise test. They're not internal or private, they are not hidden. Okay. As long ago as 2007, which makes me feel really old, I wrote this, because the TDD community understood at the time that people were going in the wrong direction, and we tried shouting a lot, but this automated software engineering kind of like paradigm had really taken over. And back then I said, when I look around now, I see a lot of people using mocks to replace all of their dependencies. My concern is they will begin to hit the fragile test issues that mocks present. Gerard Mazaros identifies the issues we hit as two specific smells: over-specified software and behavior sensitivity. So typically what happens is, in a strongly typed language like Java or C#, you say, oh, my collaborators, I need to be able to substitute those. I will create an interface for them. So rather than newing anything up in the constructor of my class, if I want to basically use components so I can effectively compose behaviors rather than using inheritance, I have to inject all my dependencies. Previously, we tended to use dependency injection for things like strategy pattern, or effectively to support layering, where effectively I couldn't know basically about the concrete class and a layer that was above me, for example. But suddenly, we were using interfaces to inject all of our dependencies. And the result of that was we couldn't anymore use any kind of like what we call poor man's DI, where composition was from the root and everything just, well, I can just new up my dependencies, etc., and pass in some config. Suddenly we had these really long chains of interfaces in our constructors, which meant we needed to all start using IOC frameworks to build our code bases. Right. If you ever wondered, hang on a minute, my class seems to be this mess of dependencies, I can't actually create anything without IOC frameworks, is this the right thing? And the answer is probably no. We've kind of trapped ourselves, right? What do we mean by behavior sensitivity? We mean the problem is that essentially we should be able to change the implementation details of our code without breaking tests. Right. Tests are intended to focus on the contract, but actually our tests are focused on the implementation details. And generally what you see this behavior when you try and change something, and then you go, I got to fix the 300 broken tests because I changed the way we called that interface on that other class. Right? That shouldn't happen. You're changing an implementation detail. That shouldn't break your tests. And that also leads to this problem where people stop refactoring, or they try and work around basically avoiding making changes because it's kind of like, yeah, I can't do that. So many tests will break. That will take us days to fix. Let's do something else. But tests were supposed to make our code more supple. They're supposed to enable refactoring. Why are they preventing us from refactoring? Okay. So the principle you need to understand, a principle that's been around since the beginning of TDD, is that developers write developer tests, sometimes called programmer tests, not unit tests. It's worth noting, so when Kent writes TDD, by example, Kent is not the originator of TDD, and he would admit to that, I think. Kent is documenting a practice that he and others in various software communities have been using for some time. And if you go and read TDD, by example, it has information on mocks, acceptance test-driven development, lots of ideas that people think came much later, they already knew about, they already understood, and it's discussed, right? So he's documenting practice that people are using for a wider audience. And Kent says, I call them unit tests, but they don't match the accepted definition of a unit test very well. This is the only reference to unit tests in the entire book. You can go and search it, that's the only time it's mentioned. What it means is in casual conversation, we occasionally say unit tests. And when he built JUnit, he referred to them as unit tests. It's one of these kind of like, billion-dollar mistakes, right? A bit like using the word micro with microservices, right? People started to go off on a tangent of completely the wrong set of ideas, and they brought in units from automated software engineering. Okay. Right. So we can understand what we should be doing better if we look at refactoring. So this is Martin Fowler's definition of refactoring. A change made to the internal structure of software to make it easier to understand and cheaper to modify without changing its observable behavior. So refactoring is very clear, right? I've got some observable behavior, things that other people depend upon that my class effectively does, right? If I want to change how it does it, a more efficient algorithm, better structure, effectively breaking it into small classes, I should be able to do that, right? Guided by my tests to ensure that effectively I don't break anything. So red-green refactor is the TDD cycle. Refactor is the last step. Often you see people practicing TDD going, yeah, I mean, we just do a lot of red and green. We never really refactor, right? That's a smell. It's a smell that effectively what's happened is you've got a design up front you are now trying to get under test. Because in the green phase, what you should be doing is anything you can to find the algorithm that you need to pass the test. So you can go and copy code from Stack Overflow, copy paste it, that's absolutely fine in the green phase. You can go and ask ChatGPT to tell you how you should write that code and cut and paste it in. That's absolutely fine in the green phase. You will make the code good once it passes the test because now you know exactly the code you need to pass the test. And you can then refactor to write high-quality code, right? You can improve on what ChatGPT gave you. Right? So your code is exposing a contract. And what we want you to do is test that contract, test I can implement that contract, and then have tests which say I continue to meet that contract. But you should be able to change how you implement that contract without breaking any of your tests. And the problem with mocks is that every time you're trying to change the implementation details, you will keep breaking your tests. Kent Beck said, basically, I think somewhere in mid-teens, basically, if a program's behavior is stable from an observer's perspective, no tests should change. In other words, when I'm refactoring and I change the contract, I change the implementation rather than the contract, then I shouldn't change any tests, right? So it's a contract-first approach to testing in TDD, right? Behavior is the contract, the API that you are exposing, in other words, the public methods of a class, right? Okay. And again, Kent said even more recently, because this whole thing, you know, we never seem to win against the bad ideas of automated software engineering, tests should be coupled to the behavior of code and decoupled from the structure of code, seeing tests that fail on both counts. In other words, the tests express the contract that you want to see from that particular class, right? Not how you've chosen to implement that. There was a big kind of meetup with DHH, Greater Ruby on Rails, enfant terrible of our industry, Kent Beck, orchestrated by Martin Fowler, because DHH, in his usual way to obtain clicks, had effectively said, I'm done with TDD, and I feel good about saying that. It's basically not done me any good. I end up with these test suites that make changing my code hard and everything else, right? And the thing is, I think, to be fair, what he'd done is fallen into the very much the automated software engineering, unit test-based approach, effectively, to testing. And Kent said in that interview, that the dialogue that Martin basically created between the two of them, my personal style is I just don't go very far down the mock path. Your test is completely coupled to the implementation, not the interface. Of course, you can't change anything without breaking the tests. Right. So we don't do this kind of mock-driven testing, right? Because that means effectively we are observing the thing under test by indirect outputs, not by simply saying something along the lines of, there is state before, there is state after, and I've somehow transformed it, right? Preconditions and postconditions. That's really what you want to focus on, right? Preconditions and postconditions. What did the world look like before I did this? Exercise this behavior, what does the world look like now? Okay. So, this is the definition, effectively, of a unit test, right? Failure of a unit test shall implicate one and one only unit, a method, class, module, or package. So unit tests do defect localization via substitution. Okay. This is the definition of a programmer or developer test that you use in test-driven development. Failure of a programmer or developer test under test-driven development implicates only the most recent edit. So the way you do defect localization is I have a suite of green tests. I make a small change to my code. If any tests now go red, which used to be green, the defect is localized to the code I just wrote. This is the reason in TDD we recommend that you take small jumps. What's the smallest increment of behavior that you could now get under test? Because that localizes the defect. So Kent has a thing about driving in gears, which I think must confuse Americans, because I'm pretty sure they drive automatic rather than stick shift. But what he's talking about is this idea that the higher the gear you're in, the more code you write at any one time, the more confident you have to be about what you're doing, the more you have to feel, I've done this 1,000 times, it's okay, I can write 80 lines of code without there being too many defects, I'm good. The less comfortable you feel, the smaller the amount of code, the narrower the test you need to write in order to essentially understand where the defects are. So I typically get questions about, oh, when you talk about TDD in this way, could I do it by TDD my HTTP API? And the answer is sure, you could, if that works for you, but you're taking a big jump. So defect localization now is right across that span of your web controller, the marshalling basically of stuff into format, et cetera, all the way down to your handler. If that's actually quite simple, maybe you're comfortable driving at the level where effectively you make those big jumps and you're okay with figuring out where defects are in that, right? If not, you want to go a bit lower, right? So maybe you want to use a ports and adapters architecture and test at the port. Or maybe it's a really complex algorithm and you want to test lower down at the individual class. But it's kind of up to you to make a choice. TDD doesn't really have a rule other than drive in a gear you feel comfortable with that you can localize the defect in the amount of code you've just committed. And if you find yourself hitting the debugger a lot, you're making too big a jump. Right? The hardcore TDD folks from back in late 90s, early 2000s used to say, oh, if you've added sort of a whole lot of lines of code and then you break stuff, just in test break, delete that code and try again, right? And it's pretty hardcore. I'm okay. I'd be like, you can use a debugger, right? But the reason they had that rule was to try and persuade people not to write 200 lines of code with each test, because you'd have to lose 200 lines of code. So that's the reason for the rule. It's trying to basically say to people, don't jump too far. Okay. But a full definition of test-driven development is, so the C2 wiki, which is kind of slowly fading in the way that, you know, our history on the internet is slowly getting killed, which is never a great thing, says, test-driven development produces developer tests. The failure of a test case implicates only the developer's most recent edit. This implies that developers don't need to use mock objects to split their code up into testable units. And it implies a developer may always avoid debugging by reverting that last edit, right? So I tend to basically, in casual conversation, where I can, try and use program and developer tests. Even I will occasionally use the word unit, right? Because it's become so prevalent. TDD is a process of discovery, right? In other words, you are seeking to effectively not do huge amounts of design up front, take your contract, and then effectively slowly explore the implementation that you need. And so you don't use mock objects to the same extent you would in this classical model. You don't need to isolate the thing under test. There are some cases of mock objects, we'll talk about them in a minute. Okay. And that means essentially you can do stuff like use new to create a class in your a component in your constructor rather than inject it. So basically liberating when you can say, hey, I don't actually need to use DI for everything, right? There is one use case where effectively we may want to think about using substitutes. So the confusion around unit test actually really stems most of all from this statement by Kent. How should the running of tests affect one another? Not at all. So when he was using unit, his thing was, your tests should be able to run in parallel. Tests need to be fast because we don't want to break your flow and force you out of basically the work you're doing in incrementally working towards solving a requirement by making you go and do I'll go and make coffee while my tests run, right? We don't want that. We want tests to be, I press a button, within 30 seconds, okay, that's all green, I can keep moving, right? Whereas if you kind of like, I run my tests, anyone fancy a coffee? Then that's a disaster because I break my flow, the model gets torn down, I have to step things up again. So Kent's thing was isolation of tests from each other. And that's why he inadvertently used the word unit. And that's what caused all the problems a little bit, right? Tests are isolated from each other so that they can run in parallel, which keeps them fast. The most common problem that causes tests not be able to run together is what we call shared fixture. In other words, that means something where effectively two tests will change the same set of state. So for example, you have a table in a database, and one thing says, I'm going to count the number of rows after I do this operation. And another test says, oh, I'm going to add some rows. And if you run those two, they're going to run in a random order. And essentially, if the one that adds the other rows runs basically at the wrong moment in time, it could affect the result of the other one. And you get this erratic test that fails occasionally, right? Some of you may have seen that, right? Or static in languages like C#, we use a static variable, so effectively you have global state, and you're basically impacting global state in your test. So where you have a shared fixture, you need to avoid the problem with the shared fixture. One way to do that is to use basically a test double, like a mock or a fake. It isn't the only way, right? You may be able to actually make sure that you protect that. You may be able to run some of those tests sequentially because you don't have too many of them. But one way to do that. So I/O is most commonly the problem we experience for shared fixtures. And so it's quite common to decide, I will replace this thing that's doing I/O, like talking to a database, with a mock in order to avoid the shared fixture problem. Okay. The other reason we may want to use a mock for I/O is just speed, right? If this thing is slow, fragile, because it involves some kind of network connection or talks to resources that might not be available, in order to avoid the problem of test break because it's fragile or tests take a long time, again, it's another reason to replace something with a mock. So TDD, by example, Kent Speck talks all about mocks, but that's the reason they want to use them, right? To allow your tests to run fast and run independently, not to isolate the thing under test. Okay. So let's dig a bit deeper. The next thing I tend to see is that people get taught, okay, before you write any method, write a test for that method. Right? So typically the rule people have is the trigger for a new test is writing a new function. Even Wikipedia, bless its heart, says, write a test that defines a function or improvements of a function. Okay, Wikipedia is very wrong. Okay, it seems to make sense, right? We talked about basically saying tests, well, you have preconditions, how does the world look before I run my test? And I have postconditions, how does the world look after I basically run my function? Seems to make sense that would be a good interception point, right? Implementation is just, how do I implement that function? There are some problems. The function basically is the system under test, is basically what we're saying, right? So we want to, testing them then becomes confirming that how functions work. So you have a function that says, for example, calculate foo, right? And you say, okay, here are my parameters. Maybe I'll do a parameterized test. And I say, effectively, I'm going to run calculate foo, and here's the results I expect when I run calculate foo. Okay. One of the questions that then comes up is, private methods. You occasionally see this. How do I get those under test? And you see people go, C# people go, use internals visible to, so you can reach in and get that one. And the answer is never test your private methods, right? They're an implementation detail. Anything that is internal or private to your module, never test it. You only test the public interface that other people depend upon. All right. Because those are implementation details, you're at liberty to change them. That's the whole reason you made them basically internal to your module or private, is so you could just change them when you felt like it, right? You only need to test the things that other people depend upon. That's where behavior is expressed. Okay. All right, that doesn't really, we'll come back to that. Often when you return to your tests, it's difficult to understand the intent. The trouble with basically the kind of get foo thing is it has a whole lot of parameterized numbers and assert values, right? And sometimes it breaks. And I go, okay, so has it broken when I give get foo 20 and 30 because I've broken the implementation of get foo? Or is the change the customer wanted mean that 20 and 30 don't have that result anymore? It's probably not clear from the test. It's just give get foo 20 and 30, check that value equals whatever, right? One of the promises we were made about TDD that people sometimes mock and laugh about on the internet because people on Twitter are experts in things, right? And one of those things they go, there was this idea we didn't need documentation anymore because our tests would be an executable specification which would enable us to understand how to use the code. Ha, ha, ha. Have you ever tried seeing any tests? Isn't that awful, right? And the answer is, the way you write tests, absolutely. I can believe that. But genuine TDD doesn't have that problem. We actually get genuine executable specifications for our code. Right? I'll explain why in a second. Okay. So, Somewhat alarmingly, perhaps, for people who like to go and use spec flow and tools like that, TDD, as in Programmer and Developer Tests by origin, say the trigger for a new test is a new behavior. That is the level TDD has always been at. So Kent Beck TDD by example, this is one of the things that Kent by example is showing you how to build TDD. We need to be able to add amounts in two different currencies and convert the result given a set of exchange rates. Not, we need to test the add amounts method and see that basically when we add 20 and 30 together, we will get 50 or whatever, all right? Add amounts, get result given a set of exchange rates. Given a set of exchange rates, when we add amounts in two different currencies, then we convert the result. We can rewrite that as what's called GWT, or given when then test, which basically is an observation from Dan North, basically. Given a set of exchange rates, when I add two amounts in different currencies together, then I get a result in the first currency. That is how TDD works, and always has done since TDD by example. Not, here is my method, I want to add one. Given the state that were before the test, when I exercise the behavior under test, TDD works against behaviors. Right. Then we expect the following changes. The same thing, so as a fourfold test model by Jared Mazarius, set up, exercise, verify, tear down. Same thing as actor range assert from Bill Wake. Right. Given a set basically of, given the word before a test, when I exercise a behavior, not a method, a behavior, which might include calls to more than one method, then we expect the following changes. Right. And it's this because Dan North created the term behavior-driven development very early on in the public life of TDD, right? Early in the noughties. Dan said, I found the shift from thinking in test to thinking in behavior so profound that I started to refer to TDD as BDD, or behavior-driven development. Note, there is no difference at this point in time between what TDD and BDD are. He simply renames TDD as BDD for his consultancy clients because he finds they are confused by the word test. They start thinking about automated software engineering and unit tests. So he says, let's just call it behavior-driven development so you understand it's about testing behaviors, not units. So this was a really important observation because it said, we're all about the contracts, we're all about the behaviors, that's what TDD does, right? Now, I would caution you that BDD has since become its own thing, and I'm pretty down on BDD too. So for those of you who are thinking, yay, I like BDD, Ian's about to tell me that's great. No, sorry. But the original blog post that Dan gave and the original kind of naming strategy where he said, it's behavior-driven development is good. Some of the things BDD has become are bad. I'll explain why when we talk about acceptance testing in a minute. All right? So BDD, all these slides, by the way, they're in my GitHub. You can just go to GitHub for Ian Cooper and presentations. Kent Beck, 7 years after, I think it's called or something, because when I wrote this, it was 7 years after in the pandemic, basically, the talk I gave in 2014. So you can find this talk in there. So those of you who want the slides, particularly to look at the little detail bits, all there for you so you can reference it later. The idea behind some of the blue text is so you can reference the material later with your colleagues who are crying when you tell them that what Ian said, right? Okay. The next test you write in TDD is just the most obvious step that you can make towards implementing a requirement given by a use case or a user story, right? However you basically decide to take in your requirements. Use cases, user stories, whatever it is you use, doesn't matter. You've got some criteria from a customer that says, well, this is the thing we want, right? And then what you need to do is say, okay, how do I make the thing we want? What are the behaviors that entails? What would be a nice contract for everyone that really expressed that so that they could really understand that's what we're trying to basically build, right? So think about how the quality of the contract from the point of view of someone using the methods that you're writing to implement it. Make it obvious how it works, right? That's the point of TDD. You can, when you write the test, you can really explore for yourself. I wonder if that API is obvious. Does it make sense? Is it self-documenting? You can do all that stuff. That's what the test is for, exploring the contract, not for adding mocks and substitutes. Okay. So the next test, right? Typically, one of the problems in development is always, what do I do next? How do I start, right? You start by saying, what is the behavior I need to implement? What is the simplest test I could write? What is the smallest bit of that functionality I could get under test, right? So what is the smallest challenge? The reason the smallest challenge is because comfort about the number of lines of code you are adding, defect localization, so try and move in smaller chunks so you get better defect localization. Okay. And the user story or use case tells you what the requirements are, right? So one or two of you may be saying, oh, that's interesting. When I do my kind of development, I end up with some unit tests that test all the little methods of my classes. Then I have SpecFlow or Cucumber or something, and that tests all the behaviors, the actual behaviors. Wouldn't that be better, Ian? Shouldn't I be using that? No. I'll talk about that in a minute. Okay. The other thing that people miss is this. You do not write new tests if you introduce methods when refactoring to clean code. So what happens typically, in the best world, right, when I get to the green phase, I write this method that's about like 100 lines long, scrolls over several pages, probably has lines that are too long, and is awful, right? Frankly awful. A ChatGPT has generated it for me, and I've just cut and pasted the goddamn thing in, right? Do that. Honestly, it's perfectly fine. Ian, go and tell your boss, Ian said that's fine. You can get ChatGPT to tell you the answer, right? GitHub Copilot will look at your test for you, and it will write the answer based on the test. The better you make the test in terms of behavior, the easier Copilot's going to find to do that for you, right? But then what you do is say, that's really unmaintainable code, Ian. I can't possibly ship that. I'd like to express intent. So I will take this chunk of methods and refactor into method that expresses intent, right? I don't need a new test. Refactoring is a safe operation. If I don't introduce branches like if statements and things like that, that code is under test. It's the test that I wrote at the beginning of this process. It's covered because essentially I'm not introducing a new branch or path, right? I'm just saying, be nice if that was a method to explain stuff. Typically, if you have a language that has access modifiers, that may be a private or internal to the module method, right? You're typically not exposing it to consumers. It's just clearing up how you implement. If I have 100 lines of code, I might say, that looks like quite a separate responsibility. It's going to be easier to maintain that by making a new class. I can refactor something into a class, right? Typical way to do that, extract the method, figure out basically what in the method should be the state that belongs to the class, it should be hidden. Create a new class, put the method across, and effectively through a constructor set the behavior it depends upon, right? I still don't need a new test, right? It is covered by the original test that expresses the behavior. You should have many less tests than you do because you are effectively only testing the observable behavior. Because I might break it into two classes, and you might go, that's made it a bit complicated. I prefer to see that all in line. It'd be easier to understand. I'm going to inline all that. And that's perfectly valid. As a team, we will eventually land on what is the most maintainable way we should do this, right? But you'll be frustrated and won't do that if someone makes a new class and it has tests. We go like, well, I have to delete all the tests. And right? Don't do that. Refactoring's changed implementation, that changes the behavior. By implication, we must be covered by the existing tests, including a new class, right? So the reason you're not refactoring quite often is because you're not understanding refactoring effectively. You shouldn't be breaking your implementation. All right. Customers write acceptance tests. Cucumber and SpecFlow plans, okay. I'm sorry. Okay. So, where do these come from? Originally, they were called functional tests because each acceptance test tries to test the functionality of a user story. The idea was acceptance tests are modeled and possibly even written by a customer, thus customer tests. Nowadays, we don't have XP-style customers. Nowadays, we have product owners or product managers or whatever your particular flavor is called at your organization. The same thing. They're just a proxy for the customer. We began to introduce proxies because we couldn't get hold of actual customers, right? Okay. So this idea from XP was originally, you got some on-site customer representative of the customer, right? They were a domain expert and they could answer questions about what the requirement was, right? And the idea is the customer defines the acceptance criteria. Haven't we just said that TDD should be working against acceptance criteria. Why do I need this additional indirection of acceptance tests then? Haven't I already got tests with acceptance criteria? Oh, okay, I understand. They're tests that are written by the product owner or the customer. They write them, not the developer. How many of you have tests written in spec flow, fitness, something like that? Come on, be brave. Okay. Keep your hands up if the customer genuinely goes and writes those tests, right? None of you. Every time I ask this question, I've never had a hand in the air, but that is their point. That is why those tools exist, for the customer to write the test directly. If you're writing the test as a developer, just use your XUnit, JUnit, NUnit tool, right? There's no point in you having the indirection of taking English language, trying to push it through something where effectively to become a real test. They're hard to maintain, they break all the time, right? So James Shaw was one of the guys that wrote Fit. Fit was a very early, basically, acceptance testing tool. It essentially worked by effectively writing its origin by using HTML tables. It later basically used wikis, and it allowed customers to write tests. So James has skin in the game, right? James actually is one of the people that wrote one of these tools. And he said, there are two problems. Customers don't participate, which eliminates the purpose of acceptance testing, and they create a significant maintenance burden, meaning acceptance testing is not worth the cost. I no longer use or recommend it. I forced teams to try and do spec flow and fitness in my younger years. They hated me, and I understand why, because I was being an idiot, right? Someone told me last night 27 is about peak Dunning-Kruger for men. I can believe it, all right? So there's no point in using things like Cucumber style or Fit, right, unless the customer is actively participating in writing the tests. And the problem is they're much harder to maintain than your unit test suite. And because they're much harder to maintain, you effectively pay a huge cost, but you're getting no benefit because it's developers reading the tests and they could have just read it in the XUnit tool. Kent Beck, well, this is me, bet you. ATD is perilous because it implies that TDD does not deal with acceptance criteria for user stories. Part of the problem with this whole acceptance test model in SpecFlow and fitness other places is it implies, well, what are the other tests for? They must be units then. They're the small bits that build up to how I implement this, right? So we've kind of helped reinforce this broken automated testing model of how we do TDD, its units and integration tests and everything else, rather than developer and programmer tests, by introducing these tools, which means we're asking the question, well, what are the developer tests for then, right? Well, there must be units. If we just said everybody test behavior in TDD, we'd realize we didn't need these tools. Excuse me. Get back again. In TDD by example. So we already knew from existing experience about the practice at the point when Kent writes the book, right? An aspect of TDD is the length of cycle between test and feedback. If the customer writes a test and 10 days later it finally works, you are staring at a red bar for most of the time, right? And that is my experience of them. What happens is we go and write a suite of tests. They can't pass until we've effectively implemented all of the code, so they're red. Because they're red, we don't do it until basically we want to ship. When we want to ship, there's this mad scramble to try and write these tests afterwards. They're not driving anything, right? So these tests spend all their time red, and they are hard to maintain. Okay. So what should you do? Customers should specify acceptance criteria. So James again, customers illustrate their descriptions with concrete examples. Programmers use these examples to guide their work. Sometimes programmers use the examples directly in their tests. More often, programmers use examples as a guide, writing a multitude of more focused programmer-centric tests as they use TDD, right? Sometimes this is called example-driven development as well. Really, it's just how we should have been doing TDD all along, right? And that helps give us self-documenting code. All right, another fallacy. It doesn't matter if you write your test afterwards, right? See, a lot of developers do this. They say, yeah, I do TDD, but I write the tests after because that's the same. I have the same effect, right? I still under test. I know some really good developers that say this, right? Okay, a development process that entails, this is what test after is. A development process that entails executing unit tests after the development of the corresponding units is finished. Okay. Let's do this one. implicitly, what this implies is that I have chosen to do my design, not by exploration through TDD, but by upfront design, which I then implement and then write tests to preserve. So the design decisions I have made have not been guided by tests and not been guided by discovery through exploration. Okay. It's a long feedback loop, because I don't write the test until the end. So I'm getting no feedback on the work as I go along. I could go in very much the wrong direction and be faced with a significant amount of rework. TDD is guiding you because it's saying only the things that the acceptance criteria require are the things that you should be writing, not the stuff. And so what happens is, if you write code that's not forced by the given requirements, which is what TDD gives you, you're engaging in speculation. Most likely you are wrong. You'll end up doing rework at the end. Typically under this kind of model, rework is about 30% of the time that you spent developing. So for 10 days, that's about 3 days worth of rework, because you realize this doesn't actually implement the requirements. And often you end up with speculative code that isn't needed, because you just say, oh, at some point, maybe we'll need to do this. So I add a whole lot of code that does that, right? So you need to do two things, right? Let me just skip on that one, I think. Okay. You need to have design help, and you need to have scope control. TDD gives you scope control because it says you only write tests in response to there being an acceptance criteria that you need to implement. So I don't write any other code. I only write code that the customer needs. I don't speculate about future implementation, because it's almost certain I'll have to rework that, right? And my design evolves to be only as complicated as I need to meet those needs, because effectively my design is informed by the test as I go. So our principle is only write production code in response to a test, right? And only write a test in response to a requirement. So I basically don't write speculative code, right? I have some acceptance criteria, and that's what drives me towards done. And so I have my contract, which I'm exposing. Okay. So Kent Beck again, need a way to think about design, need a way to think about scope control. TDD is basically designed by contract, right? Here is the contract I'm exposing to my collaborators. I don't want to write more code than is needed by given requirements. You want 100% test coverage of your code. This is a funny fallacy, but it is one, right? So even Kent says, oh, look, TDD, if it's followed basically religiously, should result in 100% statement coverage, right? If you can't write code, unless there's basically a requirement to drive that code, and you're not writing speculative code, then any code you write is in response to a test and should be behavior that's needed by that test. Therefore, you shouldn't have uncovered code, right? If in your code, code coverage tools help keep you honest, right? It's very easy to go, oh, I better have a check for if null or whatever there, right? And you don't have the actual test that conforms to that, and what you have to do is go back sometimes and say, okay, I need a test about that behavior. We all get into that, right? But in theory, if you're not writing code unless the test demands it, then you should get 100% coverage out of the box, right? Okay. But I would say there are plenty of teams out there that don't have 100% code coverage that are doing a great job. So where does this discrepancy come between the two, right? So this is why. TDD is a tool for use at some points and when you're doing development, but not all points. TDD has specific characteristics and does some things very, very well, does other things very badly. Okay. So what TDD gives you is what's called fast binary feedback. Binary, green or red, either the test passes or the test fails. Binary feedback is very easy to understand, right? I added 10 lines of code, half my tests went red. There's probably a problem in that 10 lines of code. Non-binary feedback is stuff like, you get a whole range of rows come out and you have to kind of manually compare them or whatever, or you're looking at basically a screen and trying to go, is that positioned right, effectively, etc. So that's non-binary feedback. It's quite often giving you information which you have to then interpret. Logs, for example, if you are non-binary feedback, right? So it turns out that binary feedback particularly if you can get it in like under 30 seconds, is great because it keeps guiding your development without taking too much time and context shifting for you out of your head, right? So, don't use TDD to drive visual output. You're not exploring anything when you try and test a user interface, basically, effectively, right? Some UX person has said, make this happen, right? The exploration's already been done by the UX person. You are just implementing. So use exploratory testing because these things are fragile and very slow. They're not very good for binary testing. If you need to have proof against regression, that's when you use classical automation, right? That test after approach. Similarly, if you're doing spikes or throwaway code, don't use TDD. That's not its purpose, right? Just explore the goddamn thing. Use a CLI to do it. Integration, right? There will be points, right? Particularly if you go the TDD route saying, this needs to be fast and non-fragile, where you may say, that I/O I'm going to replace with a mock or a stub, and then I'm going to need to go and implement that. So my access to the database, for example, or my access to a messaging system or whatever, right? To implement that, I've now got an interface which tells me what the actual code under test needs, and I've got an SDK somewhere that tells me how I actually implement that. You're not exploring anything. The contract already exists, right? What you want to do is just implement it. So implement it, debug it if you have to, follow the SDK, and then afterwards write some regression tests to say, I want to keep this working. So that's a point where you may want to use classical automated testing, right? And do a test after approach. Okay. And don't drive third-party code, right? You bought third-party code to speed things up. Don't test drive third-party code. So what this leads to usually is what we call the testing pyramid, right? Some folks are down on the testing pyramid. I still am good on the testing pyramid. Okay. So what happens is, as you go up the pyramid, your time to feedback increases. It's slower to get the results of these tests. Slow means context shifting for a developer, which is expensive. The whole thing, you get someone really interrupts you for 10 minutes and you're like, oh, where was I? Right? It takes 20 minutes to get back. We don't want that. So slow means context shifting. And basically, effort means how binary was it? How much work do I have to do to interpret the results? And fragility, how much am I getting false positives where test breaks, yeah, because basically we didn't have access to that QA environment or whatever, right? The more fragile something is, the more time it will take us to essentially investigate every time, go, oh yeah, those tests always break, right? We've all got them in suite somewhere. Someone goes, that test is ready. Someone goes, yeah, that always breaks. Don't worry about it, right? And that is a burden, right? Because now I don't trust results, etc. So developer tests, right? Have some acceptance criteria. Look at the next smallest bit of behavior I could implement. Write a failing test for that bit of behavior. Get it to pass. Refactor, introducing lots of lovely new classes and methods against that test I've already got. That's the sweet spot. That's where you want to be most of the time. Some things will not be suitable for that testing, right? So where you had to substitute I/O, where you need some end-to-end confirmation that things are working and all the configuration works correctly. So just basically get that working with your debugger and then write a classic automated test, which means you can then begin to use that unit integration or whatever vocabulary if you need to, right, to cover that. Then monitoring and alerting, right? Your logs are really valuable sources of information, right? Observability from traces is a really valuable source of information. Use those to then test your code. And then finally, at the top, manual testing. Manual testing is kind of dying, unfortunately. It's a bit of a slight rant from me, right? What's happened is, I mean, even Microsoft killed its software engineering test, and now we effectively just have developers everywhere. And the number of teams that have genuine QA practitioners is becoming vanishingly small. And it's an awful decision because we, as developers, tend to basically be people that go, I will make this pass. It will succeed. What you need is someone that goes, I wonder what happens if I do this really crazy thing. And you're looking at this person going, why did you do that? And it breaks, obviously, right? And the kind of people that naturally in life just seem to break everything around them because they go, oh, I wonder what happens if I press the button, right? And it's a real shame we are losing those people, but we need those, a certain number of those, to actually basically do the kind of crazy stuff that you wouldn't just think of ever doing to the thing, right? And that's manual testing. Manual testing really is still valuable, it's just you can't keep doing it all the time, right? If you want a continuous deployment model, you can't keep doing manual testing. If you build something new, it's okay to manually test that, explore it, see what was wrong, and then effectively get that kind of feedback before you ship to customers to get feedback, right? Okay. So let's review. The common fallacies people have about TDD is that it's based around unit tests, right? That's a concept from test automation, but it's not applicable to TDD. That the trigger for a new test is a new function. Before I can write a new function, I have to write a new test, right? Is a typical problem. The idea that essentially you're focusing tests around functions makes them very hard to read, right? Very hard to understand when you come back to them. Customers write acceptance tests, right? It's less of a fallacy, just more of a, it just doesn't happen, right? But customers write acceptance tests means just give up on those tools like Spec for fitness, right? Honestly, really, just give up. It doesn't matter if you test first or test last. There are people in the industry, make their living, who hate me right now. It doesn't matter if you test first or test last, right? They're two quite different strategies, right? Test first is about design and scope control. Test last is about basically regression proofing yourself against change, right? They have their point in the life cycle of doing software development. It is on the same point. And you want 100% test coverage of your code, right? Actually, that may not be the most effective way to get feedback on all of your code. Do the most effective thing to get feedback. If you find yourself writing a whole lot of tests and go, God, it would just be easy to run it, just run it. Run it and then come back and figure out how you get it under aggression, right? So developers write developer or programmer tests, right? Tests that essentially are exploring the behaviors of the system. A trigger for a new test is a new behavior, the smallest increment you can think to getting that behavior under control. Customers write acceptance criteria, right? Your product owner or someone should be telling you what success looks like, and you put that into your developer tests. You only write production code in response to a test, right? But not all of the code should be driven by TDD. So where we want to get production code under TDD control, what we do is effectively we use TDD to do it. Where we don't think that's the right model, right? Most typical one is a user interface. User interface is typically a designer has helped us design them. We are just implementing that. There is no design by contract. The contract exists. Typically, you just want to get that running and then regression proof it. There's no real exploration of the user interface. What's your red-green refactor cycle look like under that model, right? I implement a failing UI. I then get the UI to pass, and then I refactor the UI to improve its design. It doesn't make any sense, right? So just use automated testing when you do that. All right, and that's the end. I think that is on time, so I won't invite questions, but feel free to wander up, right? And for those of you that, say, oh, that's a really good idea. The slides are available. You can talk to your colleagues about it. There are versions of me doing this talk online in the pandemic, right? It's me in my room, huddled against the, the impending doom, if you need to share with anybody. But I think you might be able to, hopefully they'll record this so you can share it. My other talk, Where Did It All Go Wrong, is a bit more of a rant. If you'd like a rant, that's more of a rant to share with your colleagues instead. And then they can come to this and get specific actionable advice, all right? Thanks very much.